Hey guys, welcome to question MM390 of the Maths Methods Fortify study guide. So in this question we've got a particular town which has 20,000 citizens. From census data it is known that 1 in 8 citizens in this town are retired. There are 20 people in a cafe on a Friday morning. For this group of 20 people, p hat is the random variable of the distribution of sample proportions of retired citizens, and we're looking for the probability of p hat is greater than 0.1. So, as soon as we see the probability of p hat is greater than or less than or equal to something, all we want to do to start off with is to change that into an x value. All right, so we can treat this as a binomial distribution, okay? Because we have 20 samples or 20 trials or 20 attempts at this binomial distribution. We know that each person has a 1 in 8 chance of being retired. That's our p-value. And there's either a success or a failure in terms of, you can be retired or not retired. There's no other option, okay? So the probability, actually, our biggest thing here is the fact that p hat is equal to x over n, right? Where x is our number of retired people and n is the sample space, right? So we know that our p hat is 0.1. So we take whatever value is in here and we let it equal p hat. We don't know what our x value is, that's what we're trying to find. And our n value is 20, right? Because we're sampling 20 people. So that means that x is equal to 2. So that's really important, right? So what we're actually saying here now is that the probability that p hat is greater than 0.1 is the same as the probability that x is greater than 2. Okay? So we've linked this p hat and this x, and now we can create a binomial distribution from it, right? Because we're looking for the probability that x is greater than 2, where we've got a certain number of samples, p, and all this binomial sort of stuff. So what we get is our binomial CDF in CAS, menu 55E for me, just check what yours is, and it's going to ask you for lower, upper, n, and p, and you're going to tell it that your lower is 3, right? Because we're looking for the probability that's greater than 2, so it has to be 3 and above. There's no decimals in this binomial distribution ever, because you can't have 2.5 of a retired person, right? It has to be 2 or 3. So greater than 2 is 3, so our lower is 3, upper is 20, because that's how many people we have in total. We can't have 21 retired people because there's only 20 in the cafe, right? So it has to cap out at 20. And the n is, again, 20, because that's how many people that we're surveying. And our p is 1 in 8. Right, because each person has a 1 in 8 chance of being retired, according to our census data, which it tells us in the question. So then, putting this into our CAS and clicking enter, we get an answer of 0.4647, which means probability of x is greater than 2 equals 0.4647, and this equals probability that p hat is greater than 0.1. So that's our answer. So 0.4647 is B, and B is our final answer for MM390, guys. If you have any questions about any of this, especially this swapping over to an x value and using the binomial distribution, just hit me up in the comments below as always. Again, as always, have a great day. Thank you for watching, and I'll see you in the next video.